Lastly, we have the HLS color model, which stands for hue, lightness, and saturation. And if we look at the diagram here, this is almost identical to the HSV color model, which we learned previously. However, there seems to be an extra cone that has been added on top of the model that represented the HSV color model. Suppose if we add another top cone here, this would have actually given us the HLS model here. But there still is one very significant difference between these two models, which is previously in the HSV color model, the center point should have given us the color white here. But now in this HLS model, if we look very closely here, this color is basically the color gray. And if we want to achieve the color white in the HLS model, it's basically right on top of this diamond shape here. And if we look very carefully, the other two parameters, H and S, the hue and saturation, they are pretty much the same here as in from center to circumference. All of these colors, their varying intensities are again controlled by the S, and the hue, which was our color wheel, as in for every angle it gave us a different color, and red was at 0 degree, green was at 120 degree, and blue was at 240 degree. These two have the same work mechanism which it does in the HSV color model. But the lightness, or the new parameter L here, this one, which was V in the previous model, this now varies from 0 to 1 again, as in when it's 0 we get the color black, and when it's 1, no matter what the saturation or hue is, we get the color white. And at the center, which was previously white, we get the color gray. And if you are intuitive enough, imagine if I draw a perpendicular height connecting the top of this diamond to right at the bottom of this diamond. Any color that I will get joining this line from the top to bottom will basically again be monochrome colors, varying from black to the middle, which was gray, to the top, which is white. And again, the application of the HLS color model is again image editing, where the color pickers or designing tools are used, and also because of this lightness parameter, we can easily adjust the brightness here again. If we see a side-by-side comparison between HSV and HSL, we see that at the top this was white, but in the HLS model, the top part is basically white. And if we cut it open and see what color is at the middle, you'll see that it's the color gray. If we move on to the RGB from HLS conversion again, it's basically the exact same conversion, however, with a little bit changes here and there. For the given RGB values, if they are not given scaled, we will of course scale them first, compute Cmax, Cmean, and the difference, and now we will calculate the three parameters, which are H, L, and S. In order to find L, it's basically just taking the average of Cmax and Cmean, which is Cmax plus Cmean divided by 2. For the hue calculation, if the difference is 0, that is Cmax and Cmean, they're the same, then the hue is 0. Or again, if Cmax is equal to R, we find this formula familiar. If it's green, then this is the formula, and if it's the Cmax is equal to blue, this is the formula. After finding the hue using any of these, we multiply it with 60. If it's negative, we add it with 360 at the end. As for our saturation, if again the difference is 0, then the saturation is 0 again. But if the difference is not equal to 0, how do we compute S? We will again have to look at the value of L here. If L is equal to or less than 0.5, which we will already know from here, then the formula for S will stand as difference divided by Cmax plus Cmean. And if the L value is greater than 0.5, then the value would be the same. However, there would be a 2 minus that's been added here in the formula. Using this, we would have found the L, S, and hue from RGB. And here is a conversion of them. We see that we are given RGB. This isn't normalized, so we normalize them. From here, we compute Cmax, Cmean, and the difference. Using Cmax and Cmean, we find the lightness parameter. From there, since lightness is equal to 0.5, the formula for S to find it then is just difference divided by Cmax plus Cmean, and we get saturation as 1. Lastly, in order to find H, we see that red is Cmax here and blue was Cmean. So since red is the maximum here, we use the first formula, which is this one, and we find the value by multiplying it with 60, which is 38.82 degree. Since it's not negative, we do not need to add it with 360. This is how we have found out the 3 parameters.